Chapter 30. The Hidden Cost. Storage costs show up as one line. S3, $198. Compute costs show up as one line. EC2, $2,340. Networking costs scatter across a dozen line items with names like Data Transfer Out, NAT Gateway Processing, VPC Peering Data Transfer, and CloudFront Data Transfer. Most engineers add them up once, blink, and add them up again. Tom had said, the networking costs, that's next. He pulled up the bill, found the data transfer section, added up all the line items. Networking costs in AWS are like a city's toll system. Driving into the city is free, but every tunnel you take outbound costs money, and driving between neighborhoods costs a little too. Most people don't think about the tolls until they get a bill at the end of the month and realize they've been taking the tunnel every single day when there was a free surface road the whole time. The goal of this chapter is to understand every toll booth and decide which ones are worth paying. $847 a month. We're spending $847 a month on data transfer, he said. Is that a lot? Leo asked. It's more than our S3 bill was before we optimized it, and I didn't even know we had a data transfer bill this size. Maya looked over. What exactly is data transfer? It's what AWS charges for moving bytes around. Bytes into AWS, usually free. Bytes out of AWS to the internet, charged. Bytes between services in different regions, charged. Bytes going through a NAT gateway, charged. Can you break it down? Tom could, and what he found changed how the team thought about their architecture. How AWS charges for data transfer. AWS's data transfer pricing is asymmetric. Into AWS inbound, free. You can upload as much data as you want. Out of AWS to the internet, outbound, charged. First 100 gigabytes a month is free. After that, 9 cents per gigabyte for the first 10 terabytes a month, US regions. $0.085 per gigabyte for the next 40 terabytes. Lower at higher volumes. Within the same availability zone, free. EC2 instances talking to each other in the same AZ, pay nothing. Between availability zones, same region. 0.01 gigabyte in each direction. A small but real cost. Between regions, 0.2 to 0.08 gigabyte depending on regions. Cross-region traffic is significantly more expensive. NAT Gateway, $0.045 per gigabyte processed. Every byte your private EC2 instance sends through the NAT Gateway to reach the internet, and every byte coming back is charged. CloudFront, lower data transfer rates than direct AWS to internet. $0.085 per gigabyte for the first 10 terabytes, slightly less than direct data transfer out. CloudFront often reduces total transfer costs because its edge caching means the origin serves data less often. Tom's breakdown. After categorizing every line item, outbound data to internet, $214 a month. API responses to customers globally. CloudFront cache fills when edge locations fetch from the origin. NAT Gateway Processing, $289 a month. Application servers calling external APIs. Payment processor, email service, map data. DynamoDB calls going through NAT Gateway before VPC endpoints were set up for some tables. Cross-AZ data transfer, $178 a month. Load balancer to EC2 instances, the load balancer is in one AZ, some instances in another. Application server to RDS read replica, in a different AZ. Cross-region data transfer, $166 a month. Aurora Global Database Replication, primary in US East 1, reader in US West 2. S3 cross-region replication for backups. NAT Gateway, the biggest surprise. $289 per month in NAT Gateway processing fees was the largest item, and it was partly unnecessary. In Chapter 11, Tom had set up VPC gateway endpoints for S3 and DynamoDB. These were free, but he had missed setting up interface endpoints for several other services. Systems Manager, SSM for patch management, Secrets Manager for credential retrieval, CloudWatch for metric and log shipping, SQS for message polling. Every call to these services from private EC2 instances was going through the NAT Gateway. Each call charged $0.045 per gigabyte. Interface endpoints for these services, $0.1 per AZ plus $0.1 per gigabyte data processed. At Nimbus's volume, the SSM interface endpoint would cost about $15 per month and save about $43 per month in NAT Gateway charges, because SSM generates significant data volume for patch management and parameter store calls. Endpoint costs and savings varied by service and volume. Tom calculated that setting up interface endpoints for the 4 high-traffic services would cost $62 per month total and save approximately $140 per month in NAT gateway processing. Net saving, $78 per month from endpoint setup alone. Cross-AZ traffic, an architectural question. The $178 per month in cross-AZ data transfer was trickier. Some of it was unavoidable. The load balancer distributes traffic across AZs, so some requests originate in one AZ, and the load balancer forwards them to an instance in another AZ. Some of it was optimizable. The application was configured to write to the RDS primary in US East 1A and read from the read replica in US East 1B. Every read query crossed AZ boundaries. For the reads, one solution: configure the application to prefer a read replica in the same AZ as the requesting instance. Each AZ gets its own read replica. Traffic stays local. Trade-off: more read replicas equals more cost. If the cross-AZ traffic cost is $50 per month and an additional read replica costs $190 per month, the AZ local optimization doesn't pay off. Tom calculated, at their current query volume, the cross-AZ traffic was only $31 per month of the $178, not worth adding replicas for. The other cross-AZ costs were load balancer routing and service-to-service communication, largely unavoidable at the current architectural level. This is one of those cases where understanding the cost doesn't mean you should fix it. Tom said. How much would it cost to eliminate the cross-AZ traffic entirely? Maya asked. Everything in one AZ defeats the purpose of multi-AZ. That's a $31 per month savings at the cost of losing high availability. So we leave it, she said. We leave it. This is the mature cost conversation. Sometimes you pay for something because the alternative costs more in risk.
The data transfer discount. Here's a counterintuitive fact. Serving data through CloudFront is generally cheaper than serving it directly from EC2 or S3. Direct EC2 to Internet, $0.09 per gigabyte. CloudFront to Internet, $0.085 per gigabyte. Slightly cheaper. But the real saving isn't the per gigabyte rate. It's that CloudFront caches data at edge locations. If 1,000 users request the same menu photo, without CloudFront, 1,000 requests hit the S3 origin times photo size times $0.09 per gigabyte. With CloudFront, one request hits S3 cache miss, plus 999 requests served from edge cache at CloudFront rates. For Nimbus with an 83% cache hit rate from Chapter 13, they were serving 83% of requests from edge cache. The actual origin data transfer was 17% of total requests. 83% of their outbound traffic was cached at the edge. CloudFront is not just a CDN for performance, Tom said. It's also a cost optimization for data transfer. Leo looked thoughtful. We should move all static content delivery through CloudFront, even for assets that aren't latency sensitive. Correct. If users are downloading it from AWS, it should go through CloudFront. S3 Select, reducing data transfer and queries. A subtle optimization. S3 Select allows you to retrieve only the rows and columns you need from an S3 object, CSV, JSON, Parquet, rather than downloading the entire file to filter it in your application. Without S3 Select, code example omitted for narration. With S3 Select, code example omitted for narration. S3 Select reduces the data transferred from S3 to your application. For large files with selective queries, this can be a 10 to 100 times reduction in data volume, and therefore cost. The full networking optimization, after 3 weeks of analysis and implementation, cost item, before, after, monthly saving. NAT Gateway Interface Endpoints, $289, $211, $78. CloudFront Optimization, Move More Assets, $214, $147, $67. Cross-AZ Traffic Accepted as Is, $178, $178, $0. Cross-Region Traffic Accepted as Is, $166, $166, $0. Total $847, $702, $145 per month. $145 per month. $1,740 per year in networking savings. Modest compared to compute and storage, but meaningful. More importantly, Tom now understood every line of the networking bill. He could explain each cost and had consciously decided which to optimize and which to accept. Strengths and limitations. NAT Gateway costs. Large data volumes through NAT Gateway accumulate quickly. VPC endpoints eliminate some NAT costs entirely.
Review which services your private instances call and whether endpoints are available. CloudFront for cost. Cache hit rate directly determines cost savings. High cache hit rate equals lower origin transfer plus lower overall transfer cost. Move all static asset delivery through CloudFront. Cross-AZ trade-offs. Eliminating cross-AZ traffic usually requires architectural changes that cost more than the savings. Calculate carefully before optimizing. S3 select. Significant savings for selective queries on large S3 objects. Doesn't help when you need the entire file. In the next chapter, the 6-pillar framework that asks the questions every architecture review should start with. Summary. AWS charges for outbound data, internet, roughly $0.09 per gigabyte. Cross-AZ traffic, $0.01 per gigabyte each direction. Cross-region traffic, $0.02 to $0.08 per gigabyte. And NAT Gateway Processing, $0.045 per gigabyte. Inbound data is free. Same AZ traffic is free. VPC Gateway Endpoints, S3, DynamoDB, free. Eliminate NAT Gateway costs for these services. VPC Interface Endpoints, priced per hour plus per gigabyte. Cheaper than NAT Gateway for high-volume services. CloudFront serves data at lower rates than direct EC2 to Internet and dramatically reduces origin transfer volume through caching. S3 Select reduces data transfer from S3 by filtering at the source. Some networking costs are architectural trade-offs. Cross-AZ for HA. Understand them, don't always eliminate them. Exam tips: SAA CO3 domain. Design cost-optimized architectures. Domain 4, Task 4.4. NAT Gateway versus VPC endpoints. Exam scenario. EC2 and private subnet frequently calls S3 DynamoDB. How to reduce NAT Gateway costs? VPC Gateway endpoints. Free for S3 and DynamoDB. Data transfer pricing rules. Into AWS, free. Same AZ, free. Cross-AZ, charged. Cross-region, charged, higher rate. CloudFront as cost optimization. Reduce data transfer costs for global content delivery. CloudFront. The cache layer reduces origin requests. S3 transfer acceleration. Speeds up uploads to S3 using CloudFront edge locations. Higher cost than standard S3. Use for customers uploading large files from geographically distant locations. Cross-region replication costs. Replicating data across regions incurs data transfer charges. For S3 CRR, you pay both the data transfer out rate and the S3 request cost. PrivateLink VPC interface endpoints provides private connectivity to AWS services and to services hosted by other AWS customers. More secure than going through NAT, often cheaper for high-volume services. Exercises. Exercise 1. Recall, explain the difference between a VPC gateway endpoint and a VPC interface endpoint. For which AWS services is each available? And what is the cost of each? Hint. Gateway endpoints are free but only for S3 and DynamoDB. Interface endpoints cost per hour but work for most other AWS services. Exercise 2. Exam practice scenario. A company's application runs on EC2 instances in private subnets. The instances make frequent API calls to Amazon SQS and Amazon S3. Currently, all traffic exits through a NAT gateway. The team wants to reduce NAT gateway costs. Data security must be maintained. No traffic should traverse the public internet. Which approach best meets these requirements with minimum ongoing cost? A. Create a gateway endpoint for SQS and a gateway endpoint for S3. B. Create an interface endpoint for SQS and a gateway endpoint for S3. C. Create interface endpoints for both SQS and S3. D. Remove the NAT gateway and use the Internet Gateway directly for API calls. Hint 1. Gateway endpoints are only available for S3 and DynamoDB. Hint 2. Interface endpoints are available for SQS and many other services, but cost money. Hint 3. An Internet Gateway in the private subnet route table would make it a public subnet, violating security requirements. Answer B. Explanation. S3 uses a gateway endpoint, free. SQS requires an interface endpoint, priced. This combination eliminates NAT Gateway data processing costs for both services. All traffic remains within AWS's private network. No public internet traversal. Why not A? Gateway endpoints are not available for SQS. Only S3 and DynamoDB have gateway endpoints. Why not C? While this works, It is not cost-efficient because interface endpoints for both services would cost more than using a gateway endpoint for S3. Using an interface endpoint for S3 instead of the free gateway endpoint incurs unnecessary hourly charges. Always use the free gateway endpoint for S3 and DynamoDB. Why not D? Adding a route to the Internet Gateway from the private subnet makes it a public subnet. EC2 instances in private subnets typically don't have elastic IPs, so they couldn't actually route through an Internet Gateway without additional changes, and doing so would expose them to inbound Internet traffic. SAACO3 domain, Design Cost Optimized Architectures, Task 4.4, Exercise 3, Architecture Challenge, optional.
Nimbus's West Coast users generate significant traffic.
The application serves them from US East 1, Virginia. Currently, API responses go directly from US East 1 EC2 instances to West Coast users, around 80 milliseconds, 0.09 cents per gigabyte. Menu photos go from S3 US East 1 through CloudFront Edge in Seattle, around 8 milliseconds after caching. The team is considering adding a second application region in US West 2, Oregon, for West Coast users to reduce API latency. Analyze the data transfer costs of this change. What new cross-region data transfer costs would the dual-region setup incur? Would Route 53 latency-based routing reduce or increase total transfer costs? Under what conditions, traffic volume, latency sensitivity, would the dual-region setup pay off? There's no single correct answer. The goal is to practice multi-region cost-benefit analysis. Post-credits scene. Tom closed the networking analysis. Total 3-month optimization project impact. EC2 savings plans, minus $14,200 per year. Storage, S3 plus EBS, minus $6,200 a year. Database tier, minus $11,220 a year. Networking, minus $1,740 a year. Total, $33,360 a year. He wrote it on a whiteboard in the meeting room. Leo stared at it. $33,000 and change, Tom said, per year. Per year. Priya did the math. That's $2,780 per month we were spending on things that weren't creating value. Not all of it, Tom corrected. Some of it was things we were getting value from, but paying too much for. The savings plans, we were getting exactly the same EC2 capacity, just at a better price. Maya stood at the whiteboard for a long time. When we started Nimbus, she said, every dollar counted. We could barely afford the first EC2 instance. Yes, Tom said. And somewhere along the way, we stopped watching the dollars as carefully. Growth does that, Priya said. The focus shifts to building, not optimizing. Both matter, Maya said. Both always. Add this to the wiki and set a quarterly review for cost. Tom was already opening his calendar. In the next few chapters, we zoom out from individual services and start thinking like architects.